All right, guys, this is the beginning of Chapter 5. This will be Lesson 5.1. And after all that graphing in Chapter 4, maybe you really like that, but after all that graphing in Chapter 4, we now move on. It becomes a little more algebraic. So it moves away from the graphs and back just to kind of your algebra, which, again, all this trig is good review of your algebra and geometry. And this will be a really nice review. This couple of sections will be a really nice review of some of your algebra. Okay, we're going to use trig identities. And these identities you've been exposed to already. We're going to use these trig identities and kind of manipulate them algebraically to get new facts. We start with certain identities or facts and manipulate them to get new facts. And basically what's going to happen is you have some complicated trig function, and maybe you want to rewrite that trig function and make it look simpler. You want to get it down usually in terms of sines and cosines, because those are the ones we best understand, are sines and cosines. And that's really the goal of this chapter. If I give you something complicated, can you make it a little bit simpler? And can you write it, something complicated, can you get it down in terms of sines and cosines? Okay, before we start that, just to remind you of certain identities that you'll want to know off the top of your head. As you're looking through these or paging through your notes, you think, oh, I know these. Or if you don't know those, make a mark on them. But did you know sine and cosecant are reciprocal? Did you know cosine and secant are reciprocal? And tangent and cotangent are reciprocal. You should have known those. If you didn't, look at those now. Those are in your notes, and you'll want to know those. Okay, when we say sine and cosecant are reciprocal, I've said it one way here. Another way I could have said the cosecant is 1 over the sine. Or another way to state reciprocals is when you multiply two reciprocals, a number times its reciprocal, or a function times its reciprocal function, you get 1. So when we say there's reciprocals, I wrote it here in your notes one way, but understand there's a second way and a third way to think about reciprocals. And that would be true of our other ones here too, the cosine and the tangent as well. It's written one way here, but there's two other ways to think of reciprocals as well. So we have our reciprocal functions, which you probably already were familiar with. And if not, get familiar with those. Then we have our quotient identities. Again, way back from Chapter 1 we talked about those. What does the tangent equal? It equals the sine divided by the cosine. We just talked about that when we graphed the tangent. What does the cotangent equal? It's the cosine divided by the sine. And then way back from Chapter 1, in Chapter 1 you had to know how to use these Pythagorean identities. You didn't have to have them memorized yet. Now you'll need to have these memorized, and it's okay, because the first two sets are reciprocal identities. The quotient identities are probably very straightforward at this point, because we're not adding that much. But the Pythagorean identities, you want to know them off the top of your head now. Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. And 1 plus the cotangent squared equals the cosecant squared. And we derived those back in Chapter 1 and explained where they came from. And it came from, if you remember, when we first defined the trig functions, we had an x-coordinate and a y-coordinate. We had r, and we knew the Pythagorean theorem, x squared plus y squared equals r squared. And then we picked the latter, and we came through and we divided, let's say by x squared. And here x squared of x squared was 1. We said y over x. Oh, wait, that's your tangent. So that's your tangent squared. And then r over x. Oh, wait, x over r is cosine. So r over x is secant. And you can we derived those identities back in Chapter 1. They're not real difficult to derive. But at this point, we're not as concerned about the derivation as just knowing these off the top of your head. Okay, so we've got those three sets. And we're going to use these in different ways, and the book is going to kind of push you in different ways. The first way is, again, it's a nice review of Chapter 1, but it's worth reviewing because you may have forgotten it. Find the cosine if I give you the sine. And you go back, is there any identity with sine and cosine only in it? So if you're looking right here, think, oh, here's sine and cosine. Yeah, but it's got a tangent in it also. That's no good. But down here, here's our identity with exclusively a sine and a cosine in it. So they want the cosine, and they gave me the sine. So I'll write down my identity, sine squared plus cosine squared. And again, feel free to fast forward through this if you remember this from Chapter 1. If you don't, watch it and remember it. So I've got that identity. Sine is negative 3/4, so I'll go negative 3/4. And I'll square it. Plus the cosine squared equals 1. 3/4 squared gives me 9/16. Plus the cosine squared equals 1. Subtract 9/16. So the cosine squared equals, let's see, 1 minus 9/16. I need a common denominator, so 1 is like 16/16 minus 9/16. So cosine squared is 7/16. I'll take the square root. And as I take a square root, I'm thinking plus or minus. But look, I'm in quadrant 4. Remember the good old days of A-Smart trig class? They're back. Fourth quadrant. Cosine's positive. I'll give the positive answer. I do not know the square root of 7. I'll leave it. I do know the square root of 16. It's 4. So the cosine of theta is the square root of 7 over 4. Certainly you guys had other ways of doing these problems, and that's okay too. But this would be the standard way of doing it. All right, let's try that one more time. Here's the cosecant. They wanted the cosine. Look through your identities. I will challenge you to find one with the cosecant and the cosine in there. There isn't one. But we do know cosecant from our reciprocals. If they gave me the cosecant, I know the sine is at reciprocal. So when they give you one thing, you kind of get 2 for the price of 1. And again, our question was the same as the previous. What's the cosine? And we'll use that same Pythagorean identity. Sine squared plus cosine squared equals 1. You won't always use this one, but just these two problems that happen to be the one we used. I'll put in the negative 5/8. I'll square it. I've got the cosine squared equals 1. 5/8 squared is 25 over 64. I have to subtract 25 over 64, so 1 minus 25 over 64, but 1 is like 64 over 64. And I subtract those, and look at that, I got 39 over 64. So cosine squared is 39 over 64. I'll take the square root this time, quadrant 3. A-Smart trig. Oh, shoot. Cosine is negative in the third quadrant. So I'll take the square root. I get the negative square root. I don't know the square root of 39. I'll like that. I like square root of 39. I do know the square root of 64. It's 8. And there's my answer. So a nice review of things we did in Chapter 1. But we have not done those in 2 months, so it might be a little bit rusty. Okay. Let's move on to some new problems with these same fundamental identities, and you'll see all of these on your homework. It'll be questions like this. It'll say, use your fundamental identities, those are the 3 sets we just mentioned, to get an expression involving only sine and cosine, and then simplify it. Okay, so how will you know when you're done in a question like this? When you're down to sines and cosines, and when it's as simple as you can make it in terms of you crossed out any, reduced any fractions or combined like terms or things like that. So get it down to sines and cosines is what we're looking for in these problems. So the first one is tangent times cosine. Well, the cosine doesn't bother us. We can have cosines in our answer, so we'll leave that. The tangent does bother us. And so we look back at our identities and say, well, what do I know about tangent? And there's several things you know about tangent. There's the reciprocal, which is the cotangent. Not a big help because we're trying to get sines and cosines. We come over here and we realize, oh wait, tangent is sine over cosine. So that's a big help. So I come back to my problem and say, wait a minute, tangent is the sine over the cosine. Because our goal is to get these down to sines and cosines. Those are the functions you use most frequently. Those are the ones you're the most familiar with. And then look, this is a fraction. This is over 1. Look at that. The cosines cancel out. And I've reduced it to this much simpler function. So it turns out a tangent times a cosine is really just the same thing as sine. And that's the point of what we're doing in this section. If you have a complicated trig function, can you simplify it to something easier and much more recognizable? So tangent times cosine, I don't see that real well. Sine, I know exactly what that looks like. All right, let's try another. Cotangent squared times 1 plus tangent squared. All right, first thing you notice is all the squares in there. So you might come back to the Pythagorean identities. Those had squares in them. So come down here, and you'll notice this one right here, the second one, that's straight off our identity. Tangent squared plus 1 is secant squared. So let's come back there. Tangent squared plus 1 is secant squared. Tangent squared plus 1. 1 plus tangent squared. Right there. And I'll take that out, and I'm going to put in secant squared. And you might argue with me at first and say, well, wait a minute. You don't have sines and cosines in there. And you're right. We'll get there. And let me just write this one again. This is cotangent squared. So I'll give you that point, but I made it a little simpler. And if you make these problems simpler, you're probably going in the right direction. Okay, how do I get sines and cosines? Well, cotangent. What was the cotangent? All sorts of identities, but one with sines and cosines is right there. The cotangent is cosine over sine. Or what else did we have? We had a secant. And what does the secant equal? Oh, that's the reciprocal of the cosine. So we use those two identities. And it's a matter of just kind of picking and choosing. And part of it's just trial and error. If it makes your problem simpler, use it. If it doesn't make your problem simpler, don't use it. So cotangent, we said, was cosine over sine. But guys, these were squared. So it's cosine squared over sine squared. We want to get this all sines and cosines. Secant is the reciprocal of cosine, so it's 1 over the cosine. And it's squared. And again, they make these come out nicely. And this is no exception. Look at that. We've got fractions. The cosines cancel out. And I get this answer 1 over the sine squared. And this would be the exact correct way to leave your answer. Every now and then your book will almost contradict themselves, and they won't leave 1 over sine squared. They'll leave it as cosecant squared, which again, you can say, well, that's a little simpler, true, but the directions say leave it in terms of sines and cosines, and so the answer I have boxed right here, I think, is a better answer. The book, when you check in the back, like I say, it might have cosecant squared, but better is probably 1 over sine squared. All right, that's the beginning of this. We'll continue with a little bit more of this.